we're looking at question 3, which actually just sits in the topic of kinetic particle theory, but just towards the end of the syllabus statement. So we're going to look into how melting and boiling point affects the state of metals, as well as how impurities affects the melting and boiling point. Just 5 marks, so let's dive into things. Okay, so this question, I really love it. It is a very simple question, but students tend to overthink this. So let's find out what's the easiest way to do this. Okay, so we have got 4 substances, W, X, Y, Z, and we're given melting and boiling point. Now, before something melts, it is actually existing in a solid state, and when solid melts, it will become liquid. So liquid essentially is the state between melting and boiling point, and after the liquid boil, we get gas. Okay, so we've got these 3 states of metals, and they exist based on the melting and boiling point. Okay, so with the first question, we are looking for a gas that exists at 100 degrees Celsius. So I'm trying to put the value of 100 in each row. So I'm going to look at W first. So where would 100 fit? It will not fit before -7, isn't it? It's way too big to be for that. It cannot be between -7 and -60. So the only place that 100 can exist, the value of 100 can exist, is after 60. Okay, so we're going to do the same for X. Okay, 100 cannot be between these two, so 100 will be here, because it's 100 followed by 660 followed by 2005, isn't it? So that's where we put the value of 100, and then we do the same for Y. Okay, 100 would be before 180, and then for Z, 100 again will be before 115. Okay, so you can see from here very clearly that the value of 100 that exists in that shows that falls under the category of gas would actually be W. Okay, so the answer to the first one is actually let me just change, it's actually A. Okay, so with this idea, we're going to do the same thing. Okay, I'm not going to remove my solid liquid gas, I'm going to remove my working step, and then we're going to apply parts of the question. Okay, so for this question here, we are looking at a liquid that exists in the largest range of temperature. Now, liquid is the state that exists between melting and boiling point. So we're trying to find out what is the range for each of them over here. Okay, just by a visual scanning, you would be able to tell that one of them is extremely big, isn't it? The difference between the melting and boiling point. But let's just do one at a time. Okay, for W, you use 60 minus -7. So the range or the difference here is 67 degrees. Then we have X, which is 2500 minus 660. This difference is 1840, and you do the same for Y and Z. So for Y, the difference is 1150. We are using the boiling point minus the melting point. So we find out what is the temperature range that is existing in a liquid state. So the largest value, okay, is actually X. Okay, the range of which the liquid exists in is between a range of 1840 degrees Celsius, the difference between the melting and boiling point. So therefore, X will be our answer for part 2. Okay, next one. We're looking at the substance that's a liquid at 1000 and the gas at 2000. So let's focus on the liquid first, so we won't be so overwhelmed. We're trying to fit in the value of 1000 in each of them. Again, let me clear all of this. Okay, and we're looking at 1000. Where should I put 1000? 1000 would be here for W. 1000 would be in between 660 to 2500 for X. And then we're looking at Y. 1000 would be again between 180 to 1330. And then 1000 would be beyond 445 for Z. Okay, so at this point of time, I know it cannot be W, it cannot be Z, so I've got 50% chance of getting this question correct. But there's a second part to this question, and we are looking at a gas at 2000 degrees Celsius. So where can I fit in my value of 2000? So for W, 2000 will be after 1330, whereas for X, 2000 is again existing in a liquid state, right? So the only one that fit into my criteria would be Y, right? Because at 1000 it is existing as a liquid, and at 2000 is existing as a gas. So Y would be our answers. Okay, so for this kind of question, the first thing you should be doing is to identify the solid, liquid, and gas. Solid will be before melting point, liquid between the melting and boiling point, and gas after the boiling point. And every round you just use the value given or the context given or the state given to identify your answers. Okay, hopefully this is easy for you to appreciate, and this 3 marks is easier for you to score. Next one, we're looking at the type of bonding. So based on the question, we want to find out what are the type of bonding in substance W. If you need a recap, at year 10 you would have learned covalent, you would have simple, you also have ionic, simple plus giant, and you also have metallic. Okay, so these are the 3 types of bonding that you will have learned. And the context given here is why does not conduct electricity in solid, but it conducts electricity in molten state. And for this case, it will only be ionic. Okay, so why is that so? If you still recall, an example of ionic compound would be sodium chloride, and sodium here would be our Na+, chloride would be our Cl- ion. So when it comes to ionic bonding, what's happening here is they come together and they form this really big lattice, giant ionic lattice structure. And using this structure, what's happening here is I'm going to ask you to focus on this line here, and this is what we call ionic bonding. Now, in a solid state, the ions are highly attracted to one another. They cannot move. Okay, there is no mobile ion. That's the keywords here. So in solid state, there is no mobile ions. The ions are attracted to one another. They cannot move. But if you were to melt them and they become molten, or you put them in water to dissolve them, that's the aqueous state. In these 2 states, the ions are free to move, right? So I'm just going to draw water, and then we've got positive, negative, and positive and negative ions. And these ions are able to move, and what we call mobile ions. Okay, so when the ions are able to move, they can conduct electricity, but only in molten and aqueous state. Okay, so this is the reason why in ionic bonding, the substance can only conduct electricity in molten or aqueous state because of the presence of mobile ions. Again, these are the keywords that you need to know to explain. If this question is converted to explain why ionic compound cannot conduct electricity in solid state but can conduct electricity in molten or aqueous state, then you need to bring in these 2 keywords over here. Okay, and finally, our one last question here is suggest how the melting point of pure substance changes when impurity is added. Now for this question, I'm going to draw out a glass of water. Okay, so imagine here we have pure water. We also have ice block here. That's ice. Okay, and again, this is made of pure water. Now we know that for pure water, the boiling point, or water boils at 100 degrees Celsius if it's pure. If it's an ice cube that's made of pure water, then it will only start to melt at 0 degrees Celsius. So the melting point and boiling point for pure substance is fixed. Okay, fixed melting point and boiling point if it's pure. However, if we are trying to add impurity here, let's just use some example of, say for example, in water I add sodium chloride. Okay, table salt, sodium chloride. Now this sodium chloride would be considered an impurity. So with impurity, how would it affect the melting point? Okay, so this question is focusing on melting point, so I'm going to use melting point first. So for the ice that has impurity, what's going to happen here is going to start melting at a lower temperature. So for example, it can start melting at -4 degrees Celsius, and it will continue to melt over a range. And over a range, what this means is it does not have a fixed one value. It would be melting between this value. There is no one fixed value that it will melt at. Okay, unlike pure substances which has a fixed melting and boiling point. Okay, so if you were to look at the answers at above, right, the melting point would actually cause the substance to melt over a range of temperature, and the melting point would be lower than it should be. But because this is only a 1-mark question, you only need to give either one of the 2. However, if this is a 2-mark question, then you need to give both. But the one that students tend to forget would be the first one, the melting over a range. Okay, since we're over here, might as well just talk a little bit about, just extend a little bit about on this boiling point. impurity has a very funny way of affecting boiling point and melting point. It's in the opposite spectrum. So with boiling point, if I have impurity in my water and I try to boil this water, it will start boiling at a higher temperature. Okay, so the boiling point will actually increase. Boiling point will actually increase if there is impurity. And not only that, so for example, it will start boiling only at 101, higher than it should be. And it not only just have one temperature, again, it's not a fixed value, it will boil over a range. Okay, so boil over a range. So again, with impurity, the melting and boiling point changes. For boiling point, it increases. For melting point, it decreases. But both of them would not have a fixed value. It would be over a range. Okay, so hopefully this has helped you a little bit. And this is a 5-mark question on how we can determine the state of metals using melting and boiling point, and then how impurities affects melting and boiling point. All right, see you on the other question.